Thank you all for joining virtually today. I know we've all experienced a lot of webinars, and so thanks for sticking with it. So today I will talk to you about this topic that's fairly complex about sustainability. And so just to get right to it, when we think about this topic of sustainability, it is complex. So what's on the screen now is kind of how I like to think about it. And even this is quite a simplification of how complex this topic is when it comes to sustainability in food. So sustainability itself, there's fairly wide agreement that it encompasses three different domains, right? So the environment or ecological issues, social issues, and economic issues. So all three of those domains are important, and it is about a long-term focus. However, it gets quite complex once we drill down into more specifics, right? So what's on this Venn diagram right now is just a sampling of some of the issues that can be important when we talk about sustainable agriculture and sustainable food production. So one of the things that garners the most attention is actually that environmental domain, that environmental sphere, and things like environmental footprints, right? So for example, greenhouse gas emissions, carbon footprints, right? Water footprints. These are often things we hear about when we talk about sustainability. But there's also components of social sustainability, right? Everything from, of course, nutrition and the health and well-being of people, but also culture, right? Culture and traditions, animal welfare, right? And on the economic side, right? The livelihoods of the people involved in agriculture. Can people afford food, right? So all these different things are important. And the last thing I'll just say on this is just to draw your attention to the last bullet point on the left-hand side. I think that's what's really key, is that all of these things we can say are issues that are important, but how we value them will vary person by person. And that's one of those key things to understand and respect when we have these conversations about sustainability. Those value judgments mean that everybody may say these are important, but they may rank them differently, 1 through 10, or whatever the issue list is, right? So that doesn't mean that one person that values animal welfare highest, right, is wrong compared to somebody that the affordability of food, for example, is the most important thing to them. It's just that they have different priorities. And that's what's one of the challenging things in this space, is that we have to create that recognition and that space for those different priority lists. So there is no single answer to all of this, right? I'm going to go through a lot of specifics, a lot of the science, but that's always important to keep in mind, is that it's very complex. It is about a lot of shades of gray, and these things are in flux all the time. So that's the issue of sustainability. As we know, we're living through this pandemic, this global challenge. And one of the other things that's come up a lot is the idea of resilience, right? We've seen challenges with supply chains in North America, across the whole world, challenges that have impacted farmers, lots of challenges that have impacted people that are consumers, from just them maybe losing their jobs to not having food available as readily as we expect, right? Especially in the early days of this pandemic. And so the resilience of a system, the ability of a system to deal with shocks, is also something that we have to consider as well, right? It's about balancing all these things and thinking about how robust is this system, our food system, to deal with these shocks. We have varying evidence, but I would say in large part, we've seen a lot of success, especially in the North American food system, at least, of dealing with an incredible turn on the dime of most food, especially in the United States, right? Most food going through food service to overnight switch where it all went through retail, right? That was a major supply chain disruption. It left a lot of headaches, but also we had some examples of resilience and of being able to switch things around fairly rapidly as well. So what I'm going to do in the rest of this presentation, I gave you this high level, okay, sustainability is complex, disclaimer up front, but I am going to get into more of these specifics, and particularly around livestock production and ruminant agriculture, and go through, I would say, kind of the greatest hits of things that are raised as concerns, things that are serious issues and we should look at deeply, and try to provide some context on some of the science behind each of these issues, right, as it relates to sustainability. So the first one is really kind of centered around this question, right? Are livestock eating what could be human food? What about resource competition? This is something that we see a lot, whether it's directly in terms of what the animals are eating could be human food, or the land base that's used to grow crops or to house animals, whatever it may be, could be put to quote unquote better use, right? So we'll try to tackle some of that. And some of this, again, is all about value judgments too, right? Again, when we use better that is a subjective word, right, in a lot of cases. So let's cut right to the chase on what do livestock consume globally, right? So what we're looking at here is a UNFAO study in terms of this pie chart that's on the left-hand side of the screen. So this is looking at essentially what we call the global feed ration, right? Think about the global diet for all livestock species, right? All domesticated farm animals. What do those animals actually eat? So a key takeaway from this, if we think about all the pigs, cattle, chickens, everything in the world, only about 14% of what they eat globally is actually something that is directly in competition with human food, meaning they're taking a mouthful of something that could be eaten by people, right? So 86% of what they consume are things that we humans can't eat, is inedible to us, is indigestible to us. And this is very true for our ruminant farm animal species. So think cattle, sheep, and goats, right? These animals have specialized stomachs that can digest fibrous material. So that's one of the key things. The other thing is it does vary, as I just alluded to, talking about ruminant animals. It varies depending on if we're talking about ruminants or monogastric animals like pigs and chickens. So actually pigs and chickens are very similar to us humans. They're omnivores and they're simple stomached animals. So actually their diets tend to have a little bit more competition than ruminant animals. And as I've highlighted this quote on the screen, so globally, the average is that cattle only need 0.6 kilograms of protein, human edible protein in their feed to produce 1 kilogram of human edible protein in meat and milk. So when you read that the first time, that may be like, how is that possible, right? You're making more than you're using. And I'll expand upon this on the next slide, but really it does come down to the fact that these animals are ruminants and the fact that what they're eating is of very low quality. And this is what we talk about when we say upcycling, as the headline of this slide says, right? Taking something that's of little or no value to people and making higher value products. And that's really what livestock, a key part of what livestock do within the food system is this upcycling service. So just to describe this a little bit further and provide a key example of what I've talked about of how when we look at things in different ways, we can get different answers, right? Some of this is a little bit subjective. So this is a great example looking at feed conversion efficiency across 4 different animal types. Okay, so how much feed it takes to make human food essentially in these different ways. And highlighting that when we express this type of information 3 different ways, we get 3 different answers, right? So that's always one of those things to keep in mind is that it's easy to fit your bias, if you will, or fit your priors in some of the way this data can be presented, okay? So to walk you through this slide, we're in the first column, in the dark, the bold, the black text of these numbers. This is saying how many pounds, and you can swap in your mind kilograms of feed per kilogram of live weight gain or fresh milk that gets produced, it takes, okay? So for example, the beef example is the full life cycle to produce beef, right? So beef is a fairly complex supply chain. Mama cows have calves out on pasture and rangelands. And then those animals in North America usually are mostly finished in feedlots, but it's a long-term process. So that's what that life cycle means. So it's taking into all those stages of their life. So you can see clearly there are differences between the ruminant meat, the beef, and if we put lamb up here, it'd be a similar number, compared to the dairy cows and the monogastric meat, right? So keep in mind, this is fresh milk. Milk is mostly water, so that's partially why the number looks pretty favorable for dairy cows. They produce a lot of milk every day, so it dilutes that out. So that is just straight pounds of feed. Most times people stop here and say, again, from a resource competition standpoint, there's a difference there, right? It's pretty clear. However, that doesn't take into account what I just was talking about on the prior slide, right? That when we look at cattle, they're just not eating as much human edible feed, right? So there's not as much direct resource competition there, which is really what we care about, right? Or I would argue that's what we care about. So that's what that middle column is. What are the pounds of human edible feed per pound of live weight gain or per pound of fresh milk, right? So when we look at it that way, especially when we look at the meat producing animals, a lot of those differences kind of go away, which is interesting, right? Essentially the same amount of human edible, potentially human edible inputs are going into these animals to make food, right? The third column, this is a little bit of a different way to think about feed conversion efficiency if you haven't thought about this before, but this is essentially taking what I've been saying and flipping it on its head and saying, what is the protein value to people of beef or milk or chicken or pork, okay? And when I say protein value, I mean, what is the amino acid composition and how digestible it is, which is what really matters from a human nutritional quality standpoint, right? So what is the protein value of those animal products versus the protein value of the human edible inputs going in? So this gets to this upcycling concept I talked about, right? In this case, a higher number is more desirable. It means we're generating more human high quality edible protein than we're using, right? So above 1 means the whole system is actually generating more protein than it's using. You'll notice for both dairy cows and beef, the number is well above 1. And again, this is possible just because when these animals are eating human edible inputs, it tends to be of poorer quality, especially with beef cattle. They don't eat a lot of, for example, soybean meal. They don't have as high a protein requirements. They're able to use the microbes in their guts actually as for their protein requirements. So they don't need to eat high quality protein as compared to pigs and chickens that are like us and have to eat high quality, good amino acid composition feed inputs. So takeaway from all this, it's complex. Which animal is best? It depends on how you express feed conversion efficiency, right? And this resource competition. My view of this is that third column provides a little bit more useful information, right, than the first column. But again, it's just important to be aware that there's different ways to look at this issue. So that is the direct competition. The other side of the coin, as I mentioned earlier, is land use, right? What about land? So one thing is to keep in mind, and I'll talk about this more in other examples, is that nothing is static, right? So things change over time. And this is just an example of US cropping information, just to highlight that, right? When we have advances in crop production, that actually translates into advances on animal production as well. So we're comparing 1975 to 2017. This is USDA data of corn feed use, okay? So this first row of information, this is saying how much corn in the United States goes to animal feed across all livestock species. That has actually increased over time, 52%, pretty sizable increase. At the same time, that second row, right, corn yields per acre, bushels per acre, has increased 104%. So when we put those two pieces of information together, that is that third row, right? What is the actual land area required to grow the corn grain that directly goes to all livestock in the United States? That's actually shrunk, right? Which is interesting. Again, even though we're using more corn, because the yields per acre have increased so much, the total land area has gone down, okay? So this is an example, what we could say, of decoupling total production from the resource inputs that are required. And we see that down in the last row, right? If we think about the total animal source food output from the United States, that's actually increased 95%, right? So the land area required has shrunk because yields per acre have increased, and yet total output has increased, okay? So productivity is a really key and important part of sustainability. It alone is definitely not sustainability, but this is an important relationship as we still have a growing world population and we only have one planet Earth, right? We do have to think about total land use in this way. That said, land use and land footprints, as I just alluded to, it's complicated, right? We have to think about other domains and other things that are important. One is that all land is not equal. And this is very important when we talk about land use and livestock, is that especially for, again, our ruminants, our cattle, sheep, and goats, they are often using a lot more land. They're occupying a lot more land compared to other animal species, right? But that makes more sense when we think about what type of land are they using. It's land that's usually not suitable for other uses, right? So these are just some pictures to illustrate this. Right on the far left is southern Arizona next to the US-Mexico border. And then on the right-hand side is in Colorado at 10,000 feet elevation, right? Both of these areas are not going to be very suitable for growing broccoli, for example, right? But they can produce human food when we have grazing animals on those landscapes, right? And they can coexist with nature in those situations. And that coexistence part is really key because land use can be multifunctional, and that's another key aspect, right? Things are not just put in one category. We have examples of nature coexisting, land sharing, right? nature coexisting with agriculture, but also different forms of agriculture occupying the same acre or hectare of land, right? So this is an example from the US state of Oklahoma. These cattle are actually grazing winter wheat, okay? So in that part of the world, the wheat gets planted somewhere around Labor Day, and in the US, it's early September. And those cattle will be put on somewhere in November or December and start grazing for a few months. Those animals can, after they've gained body weight grazing this wheat, they'll be often removed, and then the wheat itself will be allowed to grow to maturity and then will be harvested for human food, right? And when that wheat gets milled and maybe gets turned into flour that maybe will go into bread products, right? One of the byproducts from that milling process is wheat middlings that can often get fed back to cattle, right? So hopefully that makes sense. As you look at this picture, there's a connection there, right? You can say, well, the bun and the burger are coming from 1 acre, essentially. We have that connection of 2 food products coming from a single acre. And then finally on land use, the other thing to consider is that just minimization, even that example I gave you earlier of the corn acres itself, is not always the only end all be all, right, of consideration, right? And this is just an example from where I'm located in New York State, USDA data looking at soil erosion. And this is another very key issue across agriculture and food production in North America and around the world, of the loss of soil, right? And what we can do to preserve soil, to improve soil health, right? Lose fewer nutrients and lose less topsoil, which is incredibly important. The key thing to look at here, though, is when we think about cultivated cropland as compared to, if you look over on the far right, pasture land, you can see a pretty clear difference in the tons of soil loss per acre, right? So essentially, when the key principles, right, of soil health, of soil preservation and conservation is keeping the soil covered and keeping a living root in the soil year round or as long as possible. And that's what pasture and rangelands do. And that is, again, an advantage from a standpoint of farming systems that integrate in ruminant livestock, because now we have a purpose to have permanent pasture lands as compared to annual crops where we're usually using a lot more tillage. But even no-till systems, of course, can reduce soil erosion quite a bit. So all these things, again, are in the background of these numbers, and that's why sometimes things like land footprints can provide some information, but not as much useful information as we think, because we're not considering all these different factors. So that's the resource competition piece, right? The answer to, are livestock eating human food? Yes, in some cases, right? But then they're also in some cases adding to the bounty. So again, it's more about that balance and how they fit in the whole system. So next topic I'll talk about is greenhouse gas emissions, just in general, some context. I'll show you US numbers, but just keep in mind, actually, this looks very similar in Canada. Our greenhouse gas emission profiles in terms of the percents are very similar. The only difference is, of course, as a bigger country with more people, the United States, we produce a heck of a lot more total greenhouse gas emissions, but the proportional breakdown is very similar across our 2 countries. So in the United States, what is animal agriculture responsible for in terms of greenhouse gas emissions? According to the EPA, it's about 4% of emissions. So these, keep in mind, these are the direct emissions that come from livestock themselves and from livestock manure. And if we look at plant agriculture, so all the cropping production, it's about 5%, right? So altogether, about 9% of US greenhouse gas emissions come from agriculture. Again, this is very similar in Canada. It's around 9 to 10% of emissions in Canada come from agriculture, okay? I've also put on here landfills, and the reason this is important and relevant to food and agriculture is because we know in the United States, the #1 source of material that goes into landfills that actually generates methane gas, which is what that 1.7% is actually food waste, right? So we in the United States waste about 30 to 40% of edible food. So that represents a loss of potential nutrition. If we think about all the impacts of producing that food and that it never actually nourished anyone. But then also at the end of life of that food waste, we potentially can produce methane gas in a landfill. So it's kind of a double whammy, food waste, and reducing waste is a really key opportunity from a sustainability standpoint. In the United States, again, similar in Canada, similar in most developed countries, transportation, electricity produce far more of our greenhouse gas emissions. All other human caused emissions, things like residential, right? Just earlier, I was sitting here and the oil company came and pumped oil into my house, right? So that's a definition of something that's probably not too sustainable. But when we live in these colder climates, heating systems, etc., there's just a lot of fossil fuel burning as a part of all those, and that really dominates the emissions profiles of our countries because we burn so many fossil fuels. So it's not that agriculture is not important. It's not that agriculture shouldn't reduce its emissions. It's just not the big source of emissions in most countries. And when we look at this globally, this is a little bit more context for you of thinking about, again, how these things change over time. This is information that's global in scope. So we're looking at global greenhouse gas emissions from 1990 to 2017. And the different colors here, the key ones just to call out, we're talking about agriculture and food production. The two bottom colors, so the blue and the red, are agriculture and agricultural land use, so any land use change, things like that. So if we add those two together, we usually say that's the whole agricultural, food, and forestry system together. So you'll notice you look at those two bars over time, they really haven't increased that much, right? Essentially, we've seen a slight increase in direct agricultural emissions and actually a decrease in the ag land emissions. So together, they're roughly the same, pretty flat over time. What's increased is this green portion. That's all the energy that's required for all the different things that we do, right? Again, so heating, electricity, on and on and on, right? So the key stats here, right? So human population from 1990 to 2017 is actually up 42%. Emissions are only up 38%. So there's been a little bit of that decoupling relationship happening. But if we think again about agriculture, we produced more food for more people, and we've essentially held the emissions constant. That's a good thing, right? We have more we can do. But from that standpoint, that's a real positive of a relationship of being able to nourish more people with less of an impact per unit of food. So with that said, another one of these key questions, right? Can we eat our way out of climate change? And this is one of these key, very hot topics right now when we look at climate solutions is propositions for dietary change. And again, the preface that I had at the beginning, a lot of this is driven by those other values that people have, and those are fair game to talk about. But if we just look at it from a climate perspective, what do we see, right? What are some of the complexities of this topic? So first, just to ground ourselves, often this dietary change idea, or the thing that, thinking about, can we eat our way out of climate change? Usually it's focused on animal source foods, particularly, right? And saying, if we eat less animal source foods, we eat more plants, we'll be able to reduce emissions, is often the argument that's made. So it's good to look at what are the trends, just as we were looking at global greenhouse gas emissions, what are the trends for consumption of these different animal source foods? So keep in mind, this is a global average, right? So we're masking all the variation that happens in individual nations. In general, nations where we have higher incomes, we have higher animal source food consumption. And that's actually what's driving the key trends that we're seeing on this chart here. This is going from 1961 to now, okay? And these different colors, hopefully it's visible, but these are all the different types, major types of animal source foods that are out there. And in general, we can see an increase, right? But they are not increasing at the same rate across all these different products, right? But as, again, people get more money in their pocket, one of the first things that they do is increase the quality of their diet, and that usually means eating more animal source foods. But the key thing I'll just draw your attention to is what I just said, right? Is that there's not the equivalent increase across all these different animal source foods types, right? So we're looking at protein supply, or just how much protein is coming from each one of these. This one at the top that's really grown pretty tremendously, actually grown about 500%, is poultry, right? So poultry has grown tremendously. The other one that's right below it is pork. Pork is also increasingly important in terms of the global protein supply. Dairy is very important for the global protein supply. What's interesting is actually the only one of these that has declined compared to 1961 is bovine meat, right? So beef and buffalo meat globally has essentially been keeping up with population growth or just slightly under it. And that's why this per capita amount has actually declined in recent years. So again, just something to keep in mind. We talk about animal source food or animal protein, we usually lump it all together, but there's differences in terms of how fast each is growing across the world. So that said, again, we've probably seen some of these type of products, especially in North America. These two have been a little bit more popular, Beyond and Impossible, but they're a part of a trend, of course, of different, so-called plant-based products that have been around for a long time. What's unique is that these companies in particular are really leaning into this climate change message and into talking about environmental sustainability and actually touching on some of these issues I've talked about. So I think this is telling. The marketing materials for Beyond is up at the top right-hand quadrant of this slide here, and they say they're talking about improving human health. We can quibble with that if we look at the different nutrition facts panels. But what I was just talking about, right? They say they were positively impacting climate change. Right? That's one of their marketing materials. Just to note, CO2 superscript. That's actually not that's not a chemical formula, right? So it's a little bit of a typo there. They also say that we're addressing global resource constraints. That's everything I just talked about that feed-food competition. And then they're saying they're improving animal welfare, but really, of course, they're making this argument because their product's not made of animals. So that's how they're making that argument. So again, just to highlight that this is relevant. This is, you all on this call probably know and understand this intimately, but this is one of those key things that's driving this conversation is some of these marketing materials. So what difference does changing diets make, right? It makes some difference, but it's probably not as big of a magnitude as is often talked about, right? So I'll walk you through this what's on the slide here. This is a study that was done a couple of years ago looking at a US specific example and essentially a what if thought experiment, okay? So the premise that was looked at with these two scientists was, what if every American became a vegan? And not just that, but we essentially removed all domesticated farm animals from the United States. What difference would that make with regard to greenhouse gas emissions, right? So as I just set that scenario up, you can think in your mind, this is probably not going to happen, right? This is completely unrealistic. So the value of this type of thought experiment is more putting an upper bound on what's possible. And hopefully that intuitively makes sense, right? It's hard to have a further reduction than truly eliminating all the farm animals, right? That would be probably your maximum bang for your buck, if you will, that you're going to get out of dietary change. So in this scenario, what they found is you indeed would reduce greenhouse gas emissions in this extreme scenario by 2.6 percentage points. Okay. And I put in parentheses what that is of global emissions. It'd be probably a little tough to pick that up and detect it globally. And in this scenario, you would actually make more pounds of food and more calories that would be available in the US food system. But we could argue, right, the US food system probably doesn't need more energy availability, right? We're pretty well set in that department in America and probably the same in Canada. But the challenge with this situation is we wouldn't have enough essential micronutrients, especially things like vitamin B12 in the food supply coming directly from food anymore because we got rid of all animal source food, and vitamin B12, right, from a food supply standpoint, is only found in animal source foods. So that's a trade-off, right, of maybe having some micronutrient deficiencies or complete lack of some of these micronutrients in our food supply, even though we've had a slight decline in greenhouse gas emissions. So that's really what's the benefit of this study, is it just highlights these trade-offs. And the other thing that's on this slide here, when we think about greenhouse gas emissions, that's what this bar chart is, plus animals, is all the greenhouse gas emissions that come from agriculture today with animals. And so you'll note this blue chunk, these are actually the greenhouse gas emissions that came from animal agriculture. So similar to that slide I showed you earlier, right? It's about 4% of US emissions. But when you get rid of all animals, you actually don't decrease emissions by 4% because you have to think about what are some of the consequences if we got rid of farm animals in the US. They serve other roles, right? One of those roles is they recycle nutrients through our agricultural system, meaning manure, right? Manure is a key source of fertilizer for some crops. So if we get rid of the manure input, now we have to use more, what we can say exogenous nutrients, right? And that's where this synthetic fertilizer increase comes from in this minus animals scenario. We also have to grow more legumes, partially for the same reason. We need more nitrogen in our cropping system to make it work. But we also would need more legumes because of the protein requirements, right, for people, because we've gotten rid of all of our animal products. So that's kind of the key thing here, is that there is no free lunch, right? There are consequences, and this essentially this rebound effect is why the total decrease of emissions is only 2.6 percentage points and not 4. And that's the final thing I'll say on the slide, not to belabor this point, but again, this assumes all livestock disappear, right? So we got to think about this critically too. This is the extreme scenario. So what if we just slightly change our diet, or just one person makes a change in their diet, right? Each person is definitely important, but you're probably not powerful enough as a consumer to change the entire food system with your food purchasing habits, right? Hopefully that makes sense. And that the fact that you're not going to influence, for example, a cattle producer in Alberta to not breed his cows, right? Essentially not sending the demand signal all the way down the supply chain means you're probably not changing anything, right? So not to make people feel helpless in this situation. I think there's lots of things we can do, again, especially on the food waste side, but changing diets to change climate change is very tough. We essentially can't eat our way out of climate change, right? And I would argue, and we can argue differently, but I would think there's actually more opportunities on how food gets to people's plates rather than thinking about how you change your plate to change climate, if that makes sense. And just to illustrate this, again, because plant and animal agriculture are so tied together, this is what makes some of these scenarios super hard, because there's so many interplays in our food web, if you will. So just an example here. What if we think about 3 breakfast beverages, right? We got orange juice, almond milk, and milk, right? Cow's milk, I've a little tongue in cheek, right? AKA the original plant-based milk. How are these things actually related, right? If we think about the US state of California, all 3 of these things are produced in that state, okay? So when we have oranges or whether we have almonds, there are different byproducts that get produced, right? Essentially, we humans, we can't eat all the plants of everything. We eat parts of them, and then there's leftovers that then often will go to livestock, right? And livestock feed. So in this case, we have almond hulls, we have citrus pulp. Both of those things can be constituents of what we call total mixed rations in agriculture, or cattle casseroles, you can think about it as. The animals will consume, and then they'll produce milk, right? So they eat plants, they produce milk. We also have these other plant-based products. Again, all good choices, they all work together. And there's a lot of examples of this as you walk through a grocery store, where you may not think different products on different shelves are actually related to each other, but in the production chain, they probably are, right? And that's because of this key stat at the bottom. For every 100 pounds, or think 100 kilos of human food that comes from crops, 37 kilos of byproducts get generated, and a lot of those get fed to livestock. So again, we can't really separate plant and animal ag apart. And I'll just belabor this point on one more slide just to highlight this, right? This is a shot in southern Minnesota, and I like this photo just because we have the crop production and the cattle right next to each other, right? So it helps illustrate when we think about what farming really is. It's really about cycling nutrients and energy through the whole system. And that's where animals and plants working together can really make a lot of sense, okay? So if we think about this system, right, we have solar energy, energy from the sun, we got carbon dioxide out of the air, right? We got water, we got nitrogen. Those are the inputs that grow plants, that drive soil microbiology, that drive the whole system to go, right? Those energy inputs and those nutrient inputs. And of course, we also have nutrient losses, nutrient outputs, right, from that system, right? From a standpoint of CO2 that the plants release, CO2 that the cattle release, right? Methane that the cattle produce, nitrous oxide emissions coming from microbes, ammonia emissions, etc. Right? So there's a cycling that's happening here, okay? There's also a cycling, again, between the plants and the animals. The animals are eating the plants, they're taking energy and nutrients from the plants and the soil, they're returning those nutrients in the form of manure, right? So hopefully this makes sense. There's a lot of cycling that's taking place, but nothing is 100% efficiency. And those losses of nutrients and energy is where we can get environmental problems, right? So if we again think about these things holistically, it's not about plant versus animal ag, right? It's more about how do we link these two things a little bit tighter together in some cases to try to minimize losses, or, as I've been saying, right, turn would-be losses into things of worth, right? This whole upcycling concept. So that statement at the bottom, I think that's one way to try to encapsulate this, right? How do we reduce losses, tighten those linkages, and maintain habitats for wildlife, right? And livelihoods for the people that are growing food, and hopefully, again, producing high quality food for consumers. So that's kind of wrapping up that idea of, can we eat our way out of climate change, right? I would challenge that premise and say, it's more about the production of food that's going to make a bigger impact than necessarily us changing our diets per se, right? Because there's so much variation in how even individual food products get produced and make it to your plate. So then the question is, if we think about this from a livestock perspective, well, can we improve livestock production enough, right? We do have a growing world population. We do have increasing incomes. And at least for the next 30 years, I would say humanity is going to go through a crunch phase where we're going to put a lot of strain on our planet because there's going to be more of us with increased consumption, right? That's just reality. So partially this will be helped by some of these things I've talked about before, right? This idea of productivity alone is not sustainability, but it sure does make a difference in this face of growing world populations. And this is just to illustrate this with a dairy cow example, okay? So this scatter plot on the y-axis, the vertical axis, we're looking at kilograms of carbon dioxide equivalents, so greenhouse gas emissions per kilogram of milk. And then on the horizontal axis is how many kilograms of milk a cow makes per year. Each one of these dots is a country average. So this is coming from the UNFAO. And the key thing to think about here, or see, visualize with this, is that as milk production per cow per year increases, the environmental impact of each kilogram of milk decreases, okay? So it's an inverse relationship. More milk per cow, we dilute out the environmental impacts. Hopefully this makes sense because in some ways it's just that we require fewer animals to produce the same amount of human nutrition, right? So one cow that's making, 40 kilos per day, right? She's going to be able to produce as much as, again, a lot more cows that are producing less. And that means less methane, less manure, less impacts per unit of human nutrition, per unit of milk that get produced. So this is a dramatic example. Again, this is where some of those opportunities are, is in those places where we have lower productivity systems and there's potential to improve. That's going to make a big difference going forward. And those are often places where there's low productivity systems where demand for animal source food is going to increase the most. So there's kind of a co-benefit there of that's where the demand is going to be. Can those countries essentially become more self-sufficient through improved productivity? That's a dairy cow example. This is another example of looking at it graphically across the globe with beef, okay? So this is looking at similar type concept. The scale at the bottom, if you can't really see it, essentially is carbon dioxide equivalents per kilogram of beef protein that gets produced. And these different colors are from green, low carbon footprints for beef, to purple, higher carbon footprints for beef. So the key thing in North America, we have carbon footprints that can be 50 times less than parts of sub-Saharan Africa and India, okay? So this is not to throw those parts of the world under the bus, because a lot of these places and countries, they're raising those animals not just for beef production, right? They're raising them from a standpoint of livelihoods, from an equity standpoint, right? So that's one of those things to keep in mind. But it does make, all of these things, again, do make a difference. And we can compare the United States to Brazil. Just to illustrate this again, then it comes down to the number of live animals that are present in these countries, right? So the US, we're the #1 beef producer in the world. We produce 27 billion pounds of beef roughly, and we have a cattle herd size of about 94 million head. So it's all beef and dairy cattle together. Brazil's the #2 beef producer in the world. They produce around 21 billion pounds of beef, but they have a cattle herd size of about 220 million head, okay? So the key thing there, not to remember those stats, is just that the US produces more beef than Brazil, and our cattle herd size is half the size, okay? So again, think that more cattle, more methane, more manure, more energy just going to maintain the animals rather than producing human food, and that's why their carbon footprint is higher as compared to North America, right? So there's opportunities there as we improve animal husbandry that can really translate into improvements in environmental health, and oftentimes, again, increasing the availability of high quality nutrition in some of these places that do have especially micronutrient deficiencies. So what are some of those opportunities? This is coming straight from the UNFAO. But again, this is this relationship of a lot of these things that are listed here are things that make a lot of sense from an animal husbandry standpoint, or just improving productivity that will often have benefits from a business standpoint of the livelihoods of folks. So animal genetics is incredibly powerful. It's been powerful for crops. It's powerful for animals as well. using proper selection techniques. And there's even new interest in selecting animals that are, for example, low methane emitting. I think we'll see a lot more progress on that in the coming years as well. Animal feeding management is really incredibly important too. Feed processing, feed additives, different biotechnologies, the health of the animals. So when you think about this, I'll expand on this in the next slide, but essentially, if an animal's sick, they're going to be expending more energy on their immune system, less towards growth, towards milks, towards eggs production, and that makes them less efficient, right? Grazing management, incredibly important, also from a carbon sequestration standpoint, or keeping carbon in the ground and not losing it. So all of these things are really important. The key quote over here, it may be a lot of jargon, but the main takeaway here is that if we maximized or optimized all these different things, the FAO estimated a few years ago that you could essentially produce the same amount of animal source food and actually produce 30% fewer greenhouse gas emissions if we focused on all these management practices and animal husbandry practices. So that's a strong relationship, right? Again, improving productivity, improving farming, the supply side of the equation can really make a big difference in terms of cutting the environmental impact of high quality food production. And the final thing, an example I'll just give you here is just really focused on animal health, right? And this is a great example that just came out from the Global Dairy Platform, where they looked at, these issues vary based on country, just like those variations in greenhouse gas emissions. So there's never going to be one single silver bullet solution, but they looked at case study example, right? In the UK, in Chile, and then in Kenya, and 3 different conditions, right? So BVDs, bovine viral diarrhea virus, so nothing that you probably have heard of, but it's an animal health issue, right? Mastitis is an infection in the mammary gland, and then just infertility, right? So actually reproductive efficiency of farm animals is really important too. So just this matrix in this table is just showing how could we improve essentially the carbon footprint of these different dairy production systems around the world if we affected these different areas, right? So again, the takeaway is that improved animal health, better animal husbandry, reducing things like heat stress is another key issue, especially as we have a changing climate and hotter climates. There's a lot of potentials for essentially win-wins where we can improve the health and welfare of animals and at the same time reduce environmental impact. So that's going to be key when we think about this question, can livestock production improve enough? It's going to be really focused on a lot of these things that come back to just good farming practices. So to wrap all this up, right, as I mentioned at the beginning, sustainability itself is complex. I've talked a lot about the environmental piece of this because this is what's garnering a lot of attention in the public discussion. But again, we had to think about those other components, right? So if we're really going to simplify a definition for sustainability, this is what's at the top of the slide, right? Saying it's producing safe, nutritious, high quality food while balancing environmental stewardship, economic viability, and social responsibility, right? That's going to vary depending on what we're talking about, where we are, but in general, those are the things that we're trying to do. There's been a lot of progress that's been made, right? But we also shouldn't rest on our laurels, right? There's lots of things that can get better. Soil erosion, I think, is a really key one. There's definitely a lot room left to reduce greenhouse gas emissions further. And also thinking about this idea that it's not either or in agriculture. It's about how these things are connected and strengthening those linkages, right? At the end of the day, livestock, they can add to the bounty on humanity's collective dinner table, right? And then we can make it even better by improving animal health and welfare in the environment at the same time. One, because it's the right thing to do, but also because we're going to get some environmental benefits when we do these things. So with that said, I'm happy to take any questions if you have them.
All right. Thank you very much, Sarah. That's terrific. We have had some questions come through, and for those of you that are joining us today, please type your questions into the Q&A, and we will do our best to get to them. One from Karen, Sarah. She says, her question is, if everyone was vegan, land use would change. So if land was just put back into nature, could that increase carbon capture and could that benefit biodiversity?
Yes, that's a great question. And that's one of those complexities of these analyses is that what if scenarios are tough to know what all the what ifs are, right? So those are some of the arguments that are made, but it's also, we don't know, right? We've seen some of those changes happen even as I sit here in New York State, right? This state has reforested as we've had agriculture essentially in the United States move further west, right? And I think you see the same thing in Canada, right? Changes over time. So that is one of those dynamics that's challenging. But then I would also say the other thing that makes it complicated is this land sharing aspect of it. And in a lot of cases, again, we have examples where we can do both on similar land, right? Or in one farm, we do have woodlots and we have crop production taking place. So it's one of those questions of what if and what is in your model. And then at the end of the day, all these things are thought experiments, and then we're still dealing with the real world as well, where the likelihood of everyone going vegan is, I would confidently say, probably 0%, right? That's what's going to happen. So
super, thank you. Next question, have there been studies done on different types of farming practices and greenhouse gas emissions? And what would be some examples of farmers or ranchers reducing their carbon footprints?
yes, great question. And that kind of comes back to these last few slides that I had, right? So we have lots of good examples of different areas of farms that have been affected, right? So on the crop production side, we see things like reduced tillage, right? No-till, using cover crops. The evidence is a little bit mixed on that, on how much soil carbon sequestration benefit you get. But there is some evidence that would point to benefits from that. So that's one of the examples of what people are doing. And there's other benefits of it beyond greenhouse gas emissions. So that's kind of one of those key points, is that even if you're not dramatically increasing soil carbon sequestration, if you're reducing erosion, you're reducing nutrient losses, that's a benefit for water quality, right? So that's one example there from a standpoint of cropping. On the animal side, there's lots of progress is happening on different manure management systems, right? So we have things like anaerobic digestion of manure, or even just covering manure systems or lagoons that can capture methane, right, and reduce greenhouse gas emissions. That can actually be a pretty dramatic impact on the carbon footprint of animal production systems if we have those, especially relevant for dairies and for swine production systems. And then a lot of these animal health measures that I mentioned, right, those are important. We haven't really documented those as comprehensively as we probably could, but it's definitely made an impact on reducing greenhouse gas emissions. From a more future-looking perspective, you probably have seen, some of you may have seen different articles on things like seaweed, feeding seaweed to cattle. So there's all sorts of research that's happening that's exciting about what can we do to reduce what we call enteric methane emissions, the methane that naturally comes from animals' digestive systems. So that's something I think we're going to see a lot more progress on cutting emissions in the next 10 years or so, just because now we really have research that's focused on it, rather than almost just a co-benefit of other things that we're doing, if that makes sense.
It does. Awesome. You mentioned the wheat millings. So that whole process of the cattle eating winter wheat, it's milled and turned into flour, fed back to cattle, the full circle. I was on a beef farm a few weeks ago, and they were taking waste carrot products, carrots that they couldn't sell, and feeding it back to their beef animals. Do you have any other like really cool examples of that you've seen that help to address this major food waste problem we have in our country?
Yeah. So I think, and that actually kind of gets back to that first question of, if we all went vegan, right? I don't think that would actually be good from a food perspective, because we need these critters to kind of help with the waste aspects of it. So one example here in New York State is we're a major apple producing state. So I've definitely been to operations where one of the innovative things I've seen is they take the apple pumice, some of the leftovers after cider making. They'll actually use it as a cover for the production of silage, which is a type of feedstuff. Essentially, we take whole corn plants and we chop them up and we ferment it for cattle feed, and they use this apple pumice as a cover, right? So essentially, it just all gets fed to the cattle at the end of the day, right? So that's one example. There's lots of vegetable production also in parts of New York, in Michigan. Some of the onions and cabbage and other things that don't make it through specs, or the overproduction in the field that haven't been harvested in a timely fashion, those will get fed back to livestock, right? So there's so many examples. It's very localized depending on what's close next to the livestock areas, right? So regionalized, but there's lots of great examples there. all across the world of things that we feed livestock, and the benefits of that.
It's an amazingly innovative story, and I think it's one that's not heard as often as it should be. Question from one of our guests, how do we convey these really complex concepts in a way that consumers can understand them and in a way that's meaningful to them?
Yeah, so it's tough because it's such a multifaceted topic. And I think if anybody's had these type of conversations, it's probably one of those conversations you address one thing and then another question pops up, right? It's a little bit of a whack-a-mole kind of conversation. I think what can be helpful is providing those specific examples, right? Like just like what we're talking about of upcycling examples and how plant and animal agriculture fit together, right? So that's one of those ways, and maybe it is one of those quick and dirty examples of like, hey, did you know that almond milk and cow's milk, even though we think about them as different products, they're actually related? You know, that might be an intriguing way to open a conversation with people and to highlight, regardless of your choice, it's great that we do have choices, but these things from a production side are connected. And that can be an opening and a way to hopefully have a further conversation. It's definitely not an area where you can just have a slogan that's going to solve all these questions at all, right? These are in-depth conversations that are good as well, because I'm intrigued and excited that people are asking these questions about food. I think that's a good thing, right? Because these are fun conversations to have as well.
And to our last point, our friends at Canola Eat Well, one of our sponsors, has just reminded us that canola meal is another really good example of that circle
That connection,
talking about. Yeah.
Yes.
You were talking, a question from Linda, you were talking about transportation as being a way to cut greenhouse gases from meat and milk. What are your do you have specifics on that?
Yeah, so one of the things to address, it's not really necessarily a question, but we often think about people will say local food to cut greenhouse gas emissions, right? And actually, in the grand scheme of things, energy use in food supply chains tends to be relatively small. It's usually more of these other emissions that come from soil that are actually more important. But in terms of cutting energy use on farms, there's lots of great examples. So one is just the direct electricity use that farms use. Especially in our more northern climates, a lot of farms have done things like update their lighting systems, which maybe doesn't sound like a big deal, but if you have a dairy farm and live in these dark months, it actually does make a big difference to upgrade to like LED lights, and you can cut a lot of energy use. On transportation specifically, there's some great examples of anaerobic digestion being used to generate renewable biogas, compressed biogas, and then actually using that in trucks to haul milk, for example, or haul other things. That's been a big development in the United States recently. The state of California has really pushed that to use more renewable biogas, and we're seeing kind of a resurgence in using anaerobic digestion, using biogas, and cutting fossil fuel use by using natural, if you will, natural gas. Yeah.
Yeah. Another question, and keep them coming, guys. This is great. When consumers think sustainability, they often think organic. And how do we communicate more effectively that sustainability can be, various forms of food production?
Yeah, I think that's tough, because I think that's definitely, we see that in the US, we see that around the world, where sometimes these labels, they've given people a simple way of just saying, hey, I want to do the right thing, and this is a label that I think is conveying what is the right thing, right? So partially it comes back to those conversations that we referenced earlier of really pulling apart. So what does that mean to you, or what are your expectations of what's coming with this label? And having that conversation to understand, maybe there's attributes that they think are encompassed in an organic label that actually aren't, which oftentimes happens, right? Or maybe there's attributes of products that they don't realize it's just conventional products you're picking up on the shelf have those same attributes, right? So that it's kind of that dual way. We see that a lot of, especially free from labels now that are very prevalent in grocery stores. It seems free from hormones, free from antibiotics, for example, and the complexities of that, and having those conversations, I think, can help draw out what is fact and what is fiction in some of these labeling claims.
Awesome. And the last question I think we've got here. So your title is Chief Sustainability Officer. which is a title that would have been unheard of a decade ago. Do you see more and more companies kind of adopting roles like yours?
Yes, I think so. I think it's something that is increasing in importance, especially as we think about these challenges, especially climate change. Corporations are taking their responsibilities seriously with regard to cutting their own emissions or the impact they can do in the world that is good. And so I think there's going to be an increasing trend of in agriculture, in food companies, in other industries to have chief sustainability officers. A lot of them already do, but this is a growing trend. And so for young people thinking about future careers, sustainability is definitely a growth area.
It's a very, very cool career. Yes. Yeah. Everybody, please join me virtually in thanking Dr. Place. As I told you, I heard her at a dairy conference last winter and immediately wrote her name down in my notebook because at that point we thought we would be hosting you in person today. And I had reached out to her, thrilled that she could still join us from New York State. So thank you a million for your time here today. For those of you who are watching online, this presentation is being recorded and will be up on the Royal Winter Fair's website in about 24 hours. So if you know of colleagues that you think should watch this, it will be available to them as well. So a million thanks for your time today.
Thanks very much. We appreciate it.